This is also a problem on statics. Problem number 20. In this problem, there is one vertical wall and a prismatic bar is hinged with the vertical wall. Okay. And the other end of the prismatic bar, that is tied by a tie rod. The tie rod makes an angle of alpha with the horizontal, and an extra weight denoted by P, it is kept on the prismatic bar at a distance x, and the total system is in static equilibrium. In such a case, you have to find out tensile force in the tie rod. Okay. And you assume the prismatic bar to be weightless. It's negligible weight. Okay. So here you can see the problem. This is the vertical wall. This is the vertical wall. This is the prismatic bar. This is horizontal. This is hinged at point A, and the other end B is tied by a tie rod BC. And the tie rod BC makes an angle of alpha with the horizontal. You can see. And this is one extra weight of P magnitude, and it is kept at a distance x from the vertical wall, and the length of the tie rod, prismatic bar, it is given, it is small L. You can see here, okay? So you have to find out tensile force in the tie bar. Or sorry, not tie bar, tie rod. Tie rod. You have to find out tensile force in the tie rod. So here AB is horizontal, and I have taken this x-axis to be horizontal, y-axis to be the vertical one. And here, the reaction at A, it is, magnitude is not known, but direction is known. The tensile force in the BC tie rod will be along BC. Now, if you extend the line of action of weight P in the vertical upward direction, it will meet somewhere here. If you join this point and this A, then you will get the direction of the reaction at A. Okay. That reaction can be resolved into two components, one along x direction, another one along y direction. Say along x direction, the reaction is denoted by R suffix x, and along y direction, reaction is denoted by R suffix y. Right? Okay. So, assuming this, you can solve the problem and say tension in the tie rod is denoted by T. Right. Then we can easily write that. So this tension T, this can also be resolved into two components, one along x, another along y. Okay. So along x, negative direction of x, it will be T cos alpha, and along y it will be T sin alpha. Right? T cos alpha and T sin alpha. So in that case, so I am showing here it is T sin alpha, and this one along the prismatic bar, it is T cos alpha. Okay? And I have already shown you, here also again I am showing, this is Rx. Okay, and along this vertical wall, this is Ry. So you know that since the total system is in static equilibrium, therefore sigma fx must be 0. So sigma fx is 0. That means what? That means Rx, it is equal to T cos alpha. Right? Rx is equal to T cos alpha, and there is no more horizontal force. Okay, and how many vertical forces are there? This T sin alpha is there. This Ry is there, and again this P is there. Direction of T sin alpha and Ry are vertically upward, and direction of P is downward. Therefore, we can write T sin alpha plus Ry, it is equal to P. This we are getting by using this sigma Fy is equal to 0. Okay, T sin alpha plus Ry is equal to P. So how many unknowns are there? Rx, Ry and T. 3 unknowns are there. So one more condition is required. That condition can be obtained by taking moment about any point. So we are taking moment of the forces about A, about the point A. Okay. If you take moment about the point A, then you can see that there is no need for Rx and Ry because they are passing through the point A. So moment will be 0. So for P, this is clockwise, so negative minus Px. Okay, P is the force and X is the perpendicular distance. And this T cos alpha, that will also pass through A, so there is no need for T cos alpha, but T sin alpha, you can use this. So here distance is L and it is anti-clockwise, so with a positive sign you have to write T sin alpha multiplied by the distance L. This is equal to 0. Okay, so we have got so far 3 equations and 3 unknowns are there, so this problem can be solved. Our target is to find out T only. Okay, tension in the tie rod. So from here what we are getting? From here we are getting T, this is equal to Px divided by L sin alpha. Okay, T is equal to Px by L sin alpha, and this is the solution. Actually this was asked in the question. Okay, so there is no need to write all these things. Anyway, I have already written. There is no need. Just taking moment, you can solve for T. Okay, so this is the answer.